Hi, my name is Graham Smith, and I'm one of the authors that helped develop the learning approach to mathematics that is found in our textbook as well as the video you are about to experience. To learn more about our approach to learning mathematics, visit the web address that accompanies this video. Now, enjoy the video. Dividing decimal numbers. This video will help you set up division exercises with decimals, divide by a one-digit divisor, write a fraction or mixed number as a decimal, estimate quotients, and divide by a multi-digit divisor. Set up and divide by a one-digit divisor. Let's start with some division notation. I have the division problem 6 divided by 3 equals 2, set up into 3 different forms that we're going to use division. The first form is the traditional one that most folks are used to. 6 divided by 3 equals 2. 6 is the dividend, 3 is the divisor, and 2 is the quotient. Using our long division format, 6 is the dividend, and that goes inside the long division box. 3 is the divisor, that goes out front of the long division box, and the quotient or answer goes in the top of the long division box. The third and final division notation that we'll use is the fraction bar. And now you'll notice that 6, the dividend, is in the numerator of the fraction. 3 is doing the dividing, so that's our divisor in the bottom of the fraction. And over on the right, the answer equals 2, which is the quotient. Now let's take a look at an example that will help you understand how to set up and divide by a decimal number. So taking a look here, we have the division problem in example 1, 17 divided by 2.5. The first thing we want to do is we want to write this as a long division problem. So we're going to set up as a long division problem, and 17 is the dividend, the thing that's getting divided, so the 17 is going to go inside the long division box. The 2.5 is our divisor, that's going to go out front. Now, we never try to divide by a decimal number. So you notice we're dividing by 2.5 here. What we want to do is we want to move that decimal until it becomes a whole number, which in this case is just going to be one place value that I have to move that decimal. Now, since I move that decimal on the outside one place, I need to match that movement on the inside. Well, we're taking a look at 17. 17 is a whole number. Where's the decimal? Well, I think the easiest thing to do is think about money. $17. Well, we know with $17 the decimal is going to go right here, and that's in fact where the decimal is in all whole numbers. It's always to the right. So that's where the decimal currently is. I need to move that decimal one place to the right to kind of match the movement that I did on the outside. So I'm going to move that decimal one place to the right. Now, we don't want to try to perform the division with all of this stuff going on, so we're going to rewrite the problem to do this division. So now out front I have the whole number 25, and then inside my division box I have 170, the decimal right there at the end, and so I'm going to bring that decimal straight up. Now I have this problem set up and I'm ready to divide. Well, I would say 25 won't go into 1, it won't go into 17, but it will go into 170. So that's where we're going to start dividing. So 25 into 170. Well, we're dividing by 25. We'll think about quarters. It would take 6 quarters to make 150. If we take 7, that'd be 175. That'd be too many, so it's going to go in there 6 times. And 6 times 25 is 150. Subtract that, we'll get 20. Now I am going to add a 0 over here. Bring that 0 down. And now we're going to go 25 into 200, and that is going to go 8 times. And 8 times 25 is 200 exactly. So when I subtract, I don't have any left. Notice that when I was dividing with decimals, I had what was a remainder of 20, and I didn't stop there and write remainder of 20. What we do with decimal numbers is we add zeros on the end. That's called annexing zeros. We add zeros and keep bringing those down until the division works out evenly, or we have to round to a certain place value. Now it's time to check your understanding of dividing by a decimal number. Hit pause on your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 1. Divide 3.4 by 0.08. Well, you can see here that we're dividing by the decimal number 0.08. So that's the divisor. That's going out front. Set this up in long division format. Inside the long division format, I have 3.4. Now, we don't want to divide by a decimal number. So we have to move this decimal number out front 2 places to make it a whole number. Now, since I moved the decimal on the outside 2 places, I'm going to move the decimal on the inside 2 places. And that's going to require me to add a 0 there. So when I rewrite this problem, I'm going to have 8 into 340. I'm going to put the decimal at the end, bring it up to the top, and now we'll start dividing. 8 doesn't divide into 3, but it will divide into 34. And 8 goes into 34 4 times. 4 times 8 is 32. Subtract, get 2. Bring down the 0. 8 goes into 20 2 times. I get a 4. Now, we don't want to write that as a remainder. What we want to do is add a 0. Bring that 0 down. And so now we're going to divide 8 into 40. And 8 goes into 40 5 times. So when I do this division problem, 3.4 divided by 0.08, I get the final answer of 42.5. When dividing with decimal numbers, do not use remainders. Instead, continue dividing until you reach an exact answer, or you can round the quotient to a given place value. It is often necessary to insert zeros when carrying out division to a desired place value. We call this process annexing zeros. Let's take a look at the definition now of annexing zeros. Inserting zeros after the last digit in the dividend is called annexing zeros. Zeros can be annexed only to the right of the decimal point and only after the last digit on the right. Now let's take a look at an example that will help you understand how to annex zeros and round a quotient to a certain place value. Example 2. Find the quotient accurate to the hundredths place in this division problem 2.6 divided by 0.6. First thing we need to do is set this problem up. So we're dividing by 0.6, that is our divisor, so that's going to go out front, and 2.6 is going to go inside the long division box. Now we don't want to divide by a decimal number, so we're going to move this decimal 1 place to the right, and we're going to match that movement on the inside. So when I rewrite my problem, I'm going to have 6 dividing into 26, and I'm going to put a decimal and bring that decimal up. Now, notice in the problem statement, they want me to round to the hundredths place. Well, to round to the hundredths place, that means I'm going to need to divide to one more place value than the hundredths place. So if I add 1 0 here, that would be a division problem, would take me out to the tenths place. So I've annexed 1 0 there. I need to annex another 0. 2 places, now that's the hundredths place. But I will also need a third 0 to the thousandths place, so I know how to round the hundredths place. And if that's not clear yet, when I get down to the answer here, you'll see what I'm talking about. So now let's go ahead and start this division. 6 won't divide into 2, but 6 will divide into 26. It goes 4 times. 4 times 6 is 24. Subtract, we get 2. Bring down my 0, and now I'm going to go 6 goes into 20. 6 goes into 20 3 times. 3 times 6 is 18. And I'm going to get 2. Now I'm going to bring down the 0. Now 6 is going to go into 20 3 times. And if this is starting to look familiar, you'll see that this pattern is happening here. 3 times 6 is 18. And I'm going to get another 2. So this 3 is going to be a repeating 3. Now, so the very next digit in this problem is also going to be a 3. Now I need this 3 in the thousandths place because that 3 is going to tell me how to round to the hundredths place. If I didn't have a digit there, I would not know how to round to the hundredths place. But since I've divided out to the thousandths place, I can now round this number. So when I round the quotient of this division problem, I'm going to get 4.33, and that is our answer, rounded accurate to the hundredths place. Now it's time to check your understanding of annexing zeros and rounding to a specific place value in a division problem. Hit pause on your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 2. Find the quotient accurate to the tens place. In this division problem, 5 divided by 0.7. Well, first let's set this up as long division. Our divisor is 0.7 and our dividend is 5. Now the decimal in 5 again is to the right. And to help us remember that, think about $5. We know the decimal needs to be the right side of that 5. Okay? We don't want to divide by a decimal number, so we're going to move this one place value. Inside, we're going to match that same movement. When I rewrite this problem, I'll have 7 going into 50. There's my decimal point in 50. I'll bring that straight up. Now, in the problem here, they want us to round to the tenths place, which means we'll need to divide to one more place value than that, which would be the hundredths place. So I'm going to next 2 zeros. The first one would be the tenths place. The second 0 will get us an answer to the hundredths place, which will tell us how to round the tenths place digit. Now that we have it set up, we're ready to divide. 7 won't divide into 5, but 7 will divide into 50. Go 7 times. 7 times 7 is 49. Subtract, we get 1. Bring down the 0. 7 goes into 10 one time. 1 times 7 is 7. We get 3. Bring down the next digit. 7 goes into 30 4 times. And we can stop right there, because now we're ready to round this answer to the tenths place. The 4 will tell us how to round that digit, and since that 4 is less than 5, we're going to keep that digit the same. So when I divide 5 divided by 0.7 and I round this answer to the tenths place, I get a final answer of 7.1. Write a fraction or mixed number as a decimal. Here in our chart here we have decimals and the fraction equivalents. We're starting out here at the top with one whole, and now we're going to start splitting that up. If we cut that in half, as a decimal that would be 0.5. As a fraction, that's 1/2. 0.5 and 1/2 indicate the same amount. If we split that up into thirds, as a decimal we get 0.3 repeating, and as a fraction we get 1/3. If we cut that into 4 equal pieces, as a decimal we get 0.25. As a fraction, 1/4. We cut it into 5 equal pieces, we get the decimal number 0.2 and the fraction 1/5. And if we cut that into 8 equal pieces, we get the decimal number 0.125 or the fraction 1/8. Decimals and fractions are both used to describe portions of a whole. Because they are used to represent the same thing, decimals and fractions can be interchanged. To write a fraction or a mixed number as a decimal, we're going to use the quotient concept of a fraction, which means we're going to divide the numerator by the denominator. Now let's take a look at some examples that will help us understand how to write a fraction as a decimal. Example 3, write 5/8 as a decimal. Well, what we want to do is we want to use the quotient concept of a fraction that says this is a division problem. And what we're going to do is we're going to take 8 and divide that into 5. You'll say, well, 8's not going to go into 5 because it's smaller. 5 is smaller than 8. Well, that's true. We're going to end up with a decimal answer here, so what we need to do is we need to add a decimal and then add some zeros to do this division. So now we'll take a look. 8 doesn't divide into 5, but it will divide now into 50. Bring my decimal up there. 8 will go into 50 6 times. 6 times 8 is 48. Subtract, we get 2. Bring down the next 0. 8 goes into 20 twice. That's 16. We get 4. Bring down the next 0. 8 goes into 40 5 times. So when I write 5/8 as a decimal, I get the decimal number 0.625. Example 4. Write 5/6 as a decimal. Well, again, we're going to take 6 and divide it into 5. Need the decimal. Add a couple zeros to start. We might need more, but we'll start right there. And now we're going to go, 6 doesn't divide into 5, but it will divide into 50. And it's going to go 8 times. 8 times 6 is 48. Subtract, we get 2. Bring down the 0. 6 goes into 23 times. 3 times 6 is 18. And we're going to get 2 again. We'll add another 0. Bring that down. And now you'll notice that we are dividing 6 right back into 20 again, which is going to go 3 times. And so you see this pattern is going to continue where this 3 is going to keep repeating. So what we want to do in this case is stop with the division, and we want to indicate that that 3 is going to repeat. So when I write 5/6 as a decimal number, I'm going to get 0.83, and that 3 is going to be repeating, and we put a little line over the top which says we're just going to keep getting that repeating 3 in that decimal number. Take a look now at example 5. Write the mixed number 7 3/4 as a decimal. Well, the whole number 7 written is in a mixed number form or a decimal form is still going to remain 7. So basically what we're going to end up with here is 7 point something and our decimal answer. All we have to do to figure out the decimal part of this is just change 3/4 into a decimal. So we're going to divide 4 into 3, add a decimal, couple zeros, and now we'll start dividing. 4 won't divide into 3, but it will divide into 30. 4 goes into 37 times. 7 times 4 is 28. Subtract, we get 2. Bring down the 0. And now 4 goes into 20 5 times. And that goes evenly. So we're done. So when I write 7 3/4 as a decimal, I get the decimal number 7.75. And now it's easy to see that the whole number part will not change when we're writing a mixed number as a decimal. All we have to do is convert the fraction into the decimal. Now it's time to check your understanding of writing fractions and mixed numbers as decimal numbers. Hit pause on your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 3. Write 1/8 as a decimal. Well, we're going to want to divide 8 into 1. So we're going to need to add some zeros here, since 1 is smaller than 8. Bring that decimal up, and now we'll start by saying 8 doesn't go into 1, but it will divide into 10. It's going to go 1 time. Subtract 8, we get 2. Bring down the 0. 8 will divide into 20 2 times. We get 16. Gives us 4. Let's add one more 0 and bring that down. And now 8 will go into 40 5 times, and that is going to go evenly, give us 40. So we know we're done with this division. So when I write 1/8 as a decimal number, I get 0.125. Question 4. Write 1/3 as a decimal. Well, we're going to start by dividing 3 into 1. Add some zeros here. 1 will not divide in 3 will not divide into 1, but it will divide into 10. It's going to go 3 times. 3 times 3 is 9. We subtract, we get 1. Notice this pattern is already starting, so we bring down the next 0. 3 will go into 10 3 times. 3 times 3 is 9. We subtract, we get 1. You can see that this pattern is just going to keep continuing. We're going to keep subtracting, bringing down the 0, which will give us a 10, and it's going to go in there 3 times. So that 3 is going to keep repeating. So when we write 1/3 as a decimal number, we're going to get 0.3 repeating. Question 5. Write 8 3/5 as a decimal. Well, the whole number part is not going to change. So we know we're going to get 8 point something. So all we're going to focus on now is just changing 3/5 into a decimal. So we're going to divide 5 into 3. Add the decimal, a couple zeros. Bring the decimal up. 5 won't go into 3, but it will go into 30. And it goes into 36 times. 6 times 5 is 30. We subtract, it's gone in there evenly, so we're done. So the fraction 3/5 is just 0.6. So when I write 8 3/5 as a decimal number, it's going to be 8.6. Estimating a quotient. Estimates are useful because exact answers are not always required. You can make an estimate and quickly move on. Also, estimating can help you catch mistakes. When you get done finished with one of these division problems, you can use a quick estimate to tell if your answer is reasonable or not. Now let's take a look at an example that will help you understand how to estimate a quotient. Example 6. We're asked to estimate the quotient of these two decimal numbers. First thing I'm going to want to do is I want to round each of these numbers to their largest place value. So taking a look at 6.2, its largest place value is 6. The 2 is going to tell us to keep that 6 the same. So when I estimate that number, I'll get 6. So I'm going to have 6 divided by, the largest place value of this next number is the 0.05. Since the number to its right is 1, we're going to keep that the same. So a good estimate for this number is 0.05. Now we're going to go ahead and perform this division. We're dividing by 0.05, and we're dividing that into 6. Here's the decimal in 6. So I'm going to move the decimal 2 places to the right outside to make that a whole number. So I want to move the decimal inside 2 places to the right. And so the division problem we're going to do is 5 into 600. 5 goes into 6 once. Subtract, we get 1. Bring down the 0. 5 goes into 10 twice. 2 times 5 is 10. Bring down the next 0. 5 goes into 0 0 times, with 0 as a remainder. So when I get an estimate for this quotient, a good approximation is that the answer is going to be somewhere close to 120. Now it's time to check your understanding of estimating a quotient. Hit pause on your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 6. Estimate the quotient of these two decimal numbers. Well, first thing we want to do is round each to its largest place value. The 3 is the largest place value of this number, and the digit to the right is 7, so that tells us we need to round that 3 up 1. So when I round this number, it'll be 0.004. And we're going to be dividing that by the next number. The largest place value is the 7, and the digit to the right is 6, so that tells us to round that one up as well. So that's going to give us 0.08. So let's go ahead and set this up as a long division problem. 0.08 is on the outside, and we're dividing that into 0.004. Now we need to move this decimal on the outside until it becomes a whole number. So 1 2 places. Same movement on the inside, 1 2 places. So we're going to have 8 going into 0.4. We're going to add some zeros here just in case we need them. Bring that decimal straight up. Now we're going to start the division. 8 will not divide into 0. It will not divide into 4. So we're going to put a 0 over that. It will, however, now divide into 40. And 8 is going to go into 45 times. 5 times 8 is 40. We subtract, we get 0. So we're done with this division problem. So when I estimate this quotient, the answer to the actual answer to this problem should be somewhere close to 0.05. Divide by a multi-digit divisor. Dividing by a multi-digit divisor uses the same procedure as dividing by a one-digit divisor. So we can do everything that we've done so far just the same. The only difference is that we're going to be dividing by a larger number, which will involve a little more guess and check. Let's take a look at example 7. In example 7, we're asked to find the quotient accurate to the tens place. We're dividing these decimal numbers. Well, first let's set this up. We're dividing by 0.24, so that's going outside, and 6.235 on the inside. Now we want to move the decimal, so we're dividing by a whole number. So that would be 2 places on the outside. I'll match that on the inside, 2 places on the inside. Let's rewrite that problem. We have 24 dividing into 623.5. Now I want to divide this or get an answer accurate to the tens place, which means I'll divide one more place after that, which is the hundredths place. So I have to annex 1 0 there. Got it set up. Now we're ready to divide. 24 will not divide into 6, but it will go into 62. So we're going to want to have some scratch work off to the side here to do the guess and check. So let's say 24 into 62. 2 times 24 is going to get us somewhere close to 50. 3 times 24 is going to get us somewhere close to 75. Well, that's too high. So we're probably going to start with 24 times 2 as our first guess. Let's see. 2 times 4 is 8. 2 times 2 is 4. So that's right. Close to 50. 48. It's probably as close as we can get without going over. So we'll write a 2 up here. 2 times 24 was 48. Now we're going to subtract. We have to borrow from the 6, which will make it a 5. I'll make that a 12. 12 minus 8 is 4, and then 5 minus 4 is 1. Now notice we chose correctly here because when we did the subtraction, we got a number that was smaller than 24. Had that number been larger than 24, it would have told us that 24 is going to divide in one more time. But we're right on the money here with 14 left over after we subtract. Bring down the 3. Now we're going to go 24 into 143. Well, you notice when we did 2, we got about 50. So 4 would be about 100. 6 would be about 150. So 6 is probably a little too high. So let's try 5. 24 times 5. 5 times 4 is 20. Write down the 0, carry the 2. 5 times 2 is 10, plus 2 is 12. So 120, oh, it's going to be close. Let's subtract and make sure that this is not more than 24 when we get done subtracting. So 3 minus 0 is 3. 4 minus 2 is 2. 1 minus 1 is 0. So notice we get 23 after we subtract, so that's good. That's smaller than the 24, the number we were dividing by. So that means that 24 went into 143 5 times. So we write the 5 up there. Okay, bringing down the next digit, the 5. Now we're going to divide 24 into 235. Notice over here with the 5, we got an answer of 120. If I doubled that, that would be 240. Just a little too high here. So I would not take 24 times 10. Instead, I would take maybe 24 times 9 as my first guess here. So I'm taking 24 times 9. 9 times 4 is 36. Carry the 3. 9 times 2 is 18. Plus 3 is 21. So 216. Yep, that seems pretty close. So looks like we're going to say that 24 goes into 235 9 times. Now when I go to subtract, borrow from the 3, which will make it a 2. Make that a 15. 15 minus 6 is 9. 2 minus 1 is 1. Now I bring down the 0. And now we're doing 24 into 190. Well, we got to do another guess and check here. Here was 5, was 120. We want to get to 190. Let's try 7. So let's try 24 times 7. See how that does. 7 times 4 is 28. Carry the 2. 7 times 2 is 14. Plus 2 is 16. 168. That seems close. Now we're going to get an answer there that is less than 24, so we don't need to actually figure that out because that meant it was going to go in there 7 times. That tells us how we need to round this 9. That means that 9 is going to go up to a 10, which is going to carry a digit over here and give us an answer, a final simplified answer of 26. Now it's time to check your understanding of dividing by a multi-digit divisor. Hit pause on your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 7. Find the quotient accurate to the thousands place of these decimal numbers we're trying to divide by. Let's set this up. So we've got 61.2 on the outside and 1.524 on the inside. We're going to move the decimal one place to the right to make that a whole number, which means we're going to move the decimal inside one place to the right. We rewrite the problem, and so we have 612. Now we're going to need to annex some zeros. We're going to round to the thousands place. Currently we're at the hundreds place. 1 0 would get us to the thousands place. The next 10,000s place digit is needed, so we know how to round the thousands place. Now we've got it set up. Let's start the division. 612 will not divide into 1. It will not divide into 15. It will not divide into 152. So we're going into 1,524. Let's come over on some scratch work. 612. First guess is maybe 2 times. 2 times 2 is 4. 2 times 1 is 2. 2 times 6 is 12. So 1224. Yes, that looks close enough without going over. So 1224. Subtract that. 4 minus 4 is 0. 2 minus 2 is 0. 5 minus 2 is 3. 1 minus 1 is 0. So we get 300. And we said now that 612 was going to go into 1,524 2 times. So let's put a 0 here. It's going to go in there 2 times. Okay, we bring down the next 0. And now we're going to go 612 into 3,000. So let's get an estimate here. 2 was 1200, about halfway, so let's try 4. 612 times 4, 8, 4, 24. Ooh, that's going to be close. Let's subtract and make sure this is okay. So 3,000 minus 2, 4, 4, 8. We're going to need to borrow here, so we start with a 3, borrow 1 from the 3, which will make it a 2. Well, that will make this next one a 10, but we're going to need to borrow from that, which makes it a 9 for the next digit. Again, it makes it 10, but we'll need to borrow from that 10 for the next place value, so it will stay 9. Finally, the last one will be a 10. 10 minus 8 is 2. 9 minus 4 is 5. 9 minus 4 is 5. 2 minus 2 is 0, and that is smaller than 612, so that means we were right on the money there. So 612 goes into this 3,000 4 times. Okay? Bring down the next 0. Now we're going to go 612 into 5,520. Well, we just did 4, and that was about 2,500. That's about halfway to 5,000. So let's try 8 now. So we'll come over here and try 612 times 8 and see how we're doing. 8 times 2 is 16. Carry the 1. 8 times 1 is 8, plus 1 is 9. 8 times 6 is 48. 4896. My guess is that's a little bit too small. So we'll have to up this one more time. 612 times 9. 9 times 2 is 18. Carry the 1. 9 times 1 is 9, plus 1 is 10. Write the 0, carry the 1. 9 times 6 is 54, plus 1 is 55. And you can see, yes, that's good. That's very close to the number we want. So we're going to say that 612 goes into this 5,520. It went 9 times. Now, we don't need to do the subtraction at this point because we're close enough. But we do need to round this answer. So let's take a look. We're rounding to the thousands place, which is the 4. The 9 will tell us to round that up. So when I get an answer accurate to the thousands place for this decimal number, I get 0.25 as my final answer. If you found this video helpful, I encourage you to check out our other videos that we have on YouTube, or visit the web address that accompanies this video to learn more about our approach to learning mathematics.